Who's ready to learn a little bit of hardware? Who's done hardware here before? Okay, so we've got a good portion of nerds, and we've got a good portion of uninitiated, right? People who haven't maybe tried. Okay, this is more aimed towards maybe the people who haven't really tried, but it's also aimed towards if you are at all interested in JavaScript, have any kind of node skills. I'm going to walk you through some of the frameworks. I'm going to talk a little bit about Electronics 101. Okay, if you know more than I, feel free to correct me after. Okay, so hardware for the soft world. How many people have heard the term IoT? Right? How many people know what it means? We've got like a couple, yeah. It is the world's most vaguest phrase, okay? It is like saying, I want a curved yellow fruit for banana, right? Totally vague. Internet of Things. And when you think about the Internet of Things, we start to think about things like, you know, maybe that's smart and shouldn't be, right? And when you think about the Internet of Things, often you think about something like this, right? This is what people think about Internet of Things. You know, I posted this on Twitter and someone actually came back to me and they're like, you know what, my cat's sick and my vet actually wants to know how often it's going to the bathroom. And I was like, and then I looked at the list, I was like, oh yeah, a cat, litter box. And then I gave him the parts of how to make it. And he was all this, super excited, right? And so when we think about the Internet of Things, it's not just about these things that are smart in your house or your apartment. It's much greater than that, but our opportunities as developers are really great in this field right now. And so I'm going to try to like expand a little bit of the understanding of why you would even want to get into this area, or why you even want to buy a device. How many people here own an Arduino at home? How many people use it every day? How many people have dust on their Arduino? Right? You did the blinky blinky, and then you're like, I don't know what the hell to do with this. It ain't, you know, after that point, right? So we're going to kind of walk through a couple of those things. When you think about the Internet of Things, one of my friends, who's a really great developer out of the UK, Seb Lee, he basically calls it stuff and things talking to the internets. Okay, and that's the way that I say it to my dad. Because my dad's like, I don't know, what is this IoT phrase, Stacey? You know, pound tag IoT, that's how he talks, right? And it's like that, it's just your stuff and things talking to the net. You have it at home whether you know it or not. How many people have a Nest at home or know what a Nest is? Nest really just, basically when they talk about disruption, that's Nest. Nest was just like, I'm gonna come in and blow this shit up, right? Because the idea of that smart thermostat at home that's now controlling your environment, it's saving you money. It's like your penny pincher in your pocket, right? Because it's monitoring everything that you're doing, it's collecting the data, it's making predictions, it's saying this is the best way for you to, you know, actually set your home, get some savings out of it, that kind of thing. Nest really changed a lot of stuff. And if you think about Nest, Nest got acquired, right? And you start to think about all these things and you're starting to see the bigger picture that other companies, whether it's going to be Google or Microsoft or Intel or Cisco or any of those big companies, you got to watch what they're doing and you got to watch their acquisitions, right? Because it starts to show you what that picture and that landscape is. And so when we talk about Internet of Things, I like to say all the things. So it can be anything, all the things, right? Your smart band, your Fitbit, something at home that's like monitoring anything in your house. There's actually a really good tumbler. It's called We Put a Chip in It. It's the only tumbler you need to go see. It's all full of ridiculous crap that people made smart, right? Like a frying pan that's telling you when stuff's done. Or like shoes that you wear and it tells you what direction to go. Okay, if I'm lost in a frickin' forest, you know, and like there's an avalanche, I'm gonna want those shoes. Until then, I don't need those shoes, right? But all sorts of these things that you're starting to see that people are starting to come across. And some of it is going to be ridiculous, right? Because that's how we work as an industry. We figure out new technology, we abuse the crap out of it because we can, and then we bring it back, and it starts to fall into place. Right? And we can say this for a lot of trends across the board, where you push that technology as far as you can, and then it swings back, right? And so we think about all the things. We think about connectivity. It's got to be connected somehow. You know, it doesn't matter how it is, Wi-Fi, Bluetooth, whatever it's making that connection, a hardwire. It's going to be connected. And then the other piece that a lot of people know but don't really get is data and analysis, right? And data, the idea that it's totally taking all that data, whether it's a weather shield or your GPS or whatever, it's taking all that data and it's storing it somewhere. That data is useless unless someone analyzes it, right? And does something with it. And so that's where you're starting to see the big portion come in right now in terms of the cloud, in terms of machine learning. How many people have heard machine learning, right? How many people really understand machine learning, right? I'm like a half hand, right? Like I'm a little scared hand. Like I think I could talk about it and not get fired, right? So you're starting to see like machine learning's really coming in order to like analyze this data, look for behaviors and patterns and make predictions, right? And so when you think about all that stuff, when you've got big data there, I think that's like my favorite image of all time. Small data, big data, right? These are kind of the components, and usually analysis will go into a third one because it's actually another stage. But that's kind of the thing you got to think about when it comes to Internet of Things. It's not just about a bracelet that you put on your arm that's monitoring like how many steps you took today, right? It's not just what it is. It has to be greater than that. And when we talk about why the Internet of Things is such a big opportunity, you know, for the average person who's making something at home, right? You're making like a little, you can unlock your door with your phone or something. When you're doing something like that, you're like a one-off, right? But when you think about big companies, right? So imagine. Okay, let me paint the picture. For some reason, you guys all own windmills. I don't know why. 400 windmills in a field. You sit out and you wake up in the morning and you have your cup of coffee and you've got 400 windmills. They're generating energy for you. I don't know what the hell you're going to do with it. Good luck with that. That's your problem. So 400 windmills, and they all have a little device on them. And each device is saying how hot are they running, how fast are they running, what's the temperature, what's the wind, what's all this stuff. It's creating all this data that it's now saving somewhere, right? You're a big company. This is how you make your money. And once in a while, your windmills will break down. And you're sad, right? You got to go and get those fixed. So you're looking out with your nice cup of coffee, you see a broken windmill, and you're like, I wish I could stop that from happening. I never know when it's going to happen. When you think about the Internet of Things, you have these devices that are reporting back, right, all this information. You might be able to do that. You may be able to predict when that's going to happen. When does it need to be maintained? When is it running hot? When is it doing all these things, right? And as a business owner with 400 windmills, which you all now are going to go off and buy on Amazon or eBay or somewhere, right? I see you all right now. One click on Amazon, 400 windmills, right? You're sitting there and you're like, I wish I could predict all this stuff. And if you could predict that, if you could predict that moment is going to happen or it needs to be maintained for a business, what that means to you is that you're going to save a lot of money, right? Because little efficiencies in big businesses results in big savings, right? So you're going to be like, 10 years later, I got $1 billion in my pocket. What am I going to do? I'm going to buy windmills for everyone, all the windmills, right? But that's why big business is really into the Internet of Things. That's why factories are into them. That's why you're starting to see it across the board, because it's allowing them to look at behavior and patterns, predict what's going to happen, and that ultimately is going to result in cost savings, okay? I don't want to talk about big business. I don't care about them, right? Because we all know that the Internet's just a series of tubes with cats in them, right? So when it comes to working with hardware and devices, a lot of people often kind of, they're tinkers. They're not really sure what to do. And I know that when I started, I'll be honest, I had an Arduino for like 5 years and it sat there. And I was like, that's nice, cool, little weight on my desk. And then I decided, no, I really want to learn this stuff and I want to understand it. And I thought, what's going to happen? What's the worst thing I can do? And I thought, like, no matter what I'm going to do, it's not going to be this. Because I have common sense, and so do you. And so when you start working with devices, I know. It's just so wrong. Anyone got a flip-flop? Want to meet me in the pool? Right? So I always think, what's the worst I'm going to do? And when it comes to hardware, I thought, the worst that could happen is that I'm going to electrocute myself and like burn off my eyebrows, right? I know that's a hot look right now, but I'm not going for it. And so, everyone's like, don't worry about it. It's only, most of your devices you're working with are 5 volts. You're not really going to get too much, going on. And I collaborated with a friend, and he knew nothing about software. And he was so afraid of software, so afraid of computers. And he's like, well, you're afraid you're going to burn yourself. And I'm afraid that I'm just going to go and basically delete my whole file system because I don't know what I'm doing. Right? And he sent me this. He sent me the screenshot, and he's like, look at this. It tells me I'm going to delete stuff. What am I doing? And I don't know how to like format this drive. And I started to realize, you know what? All of it, you can go, these things are super resilient. They don't cost that much. You can break them. This you can dunk in water. A bunch of my friends had, anyone remember Hurricane Sandy? I remember Hurricane Sandy. And a bunch of my friends' hardware got all just destroyed, dirty, everything. And I watched them put it in a thing of water. Soapy, let it dry, ran the next day, right? And, something like an Arduino. And blew my mind about devices. So what I want to do is I kind of want to walk through some devices for you and give you a sense of what's available and then kind of explain how some of them work, or, at least some of the components on them. And so when we come to devices, how many people have heard of Arduino? Right? Arduino is kind of like, I don't know, what's Arduino? It's like the love child right now, right? Like everyone loves Arduino. Arduino's open source, open hardware. Okay, that means that you can go make your own Arduino for about $10. You can go buy an IC chip, you can buy all the parts, you can do all that stuff, no problem. I've done it, it's not that hard. It's about, it costs you about $10 once you get up and running. And so an Arduino comes in many flavors, and you really need to know what you're doing with your project before you choose which Arduino. Starter Arduino is usually called an Uno. It's about $30, okay? And a lot of people start with that, but again, for Internet of Things, you've got no Wi-Fi connectivity, okay, on that board. It's just a simple board, and I'll kind of break down what it works like in a bit. But other Arduinos that you can get a Mega, you can get a Wi-Fi shield. Shields are little, you can think of them as Lego building blocks that you can just add on top of your devices, and they add behavior, sometimes servos or Wi-Fi. Okay, you can get an Arduino Young that's kind of like a Raspberry Pi. Again, these are running anywhere from $30 to $100. If you're a person who's like into Halloween costumes, right? Like my nieces, every year I'm tasked to build her something, like Minions last year, which almost killed me. Oh shit, that was for real. Like glasses and everything. If you're just looking to like have something that augments and it's not really smart and it's just gonna light stuff up or respond to stuff, you can buy cheaper like teensies or trinkets or any of those kind of things. They're usually called anywhere from $8 to $12, right? They're about this big, it's super tiny. No problem. Raspberry Pi, I'm going to say the Raspberry Pi 2. Raspberry Pi 2, you don't want to get older versions of the Raspberry Pi. Gives you more USB, more power, more everything. And the Raspberry Pi 2, the beauty of this is that if you do not know what to buy and you kind of want to play with sensors, inputs and outputs, get a Raspberry Pi. Because at the end of the day, it's a little computer running, and you can go and have a file server, right? You can go and have kind of like a MAME cabinet with your video games. You can also go and use it for other kind of physical installations. And so Raspberry Pi is actually very, very flexible in that way. Raspberry Pi was created to teach students in the UK more about computers, because they thought, oh no, like I don't want to invest in all these crazy, laptops and everything. What if we can just make a computer that's $40, right? Have at it, kids. Has anyone seen that video of the girl who's like basically hacking her dad's computer on the Raspberry Pi? She's like SSHing into her dad's computer and doing all this crazy stuff. She's like 8 years old, like hacker, watch out for her. You should just like knock off her YouTube channel right there, right? So you're starting to see like Raspberry Pi is again very popular. And again, you can run you can be running Linux on it, but you can also go and run the new Windows IoT Core on it. So if you are a .NET developer, who's a .NET developer? I feel like this is the most .NET developers I've ever talked to in my life. I actually think I'm really scared. I don't mean that in a normal way. I just mean like I normally talk open source, so it's like, I'm like, oh no, you guys are gonna say I'm wrong about everything. I'm gonna get fired, right? So Raspberry Pi, again, you can plug in your monitor, you've got HDMI, you got everything that you need there. Tessel, how many people here are JavaScript people? Right? How many people here want to admit they're JavaScript people? Yeah. Oh, we got a couple. Okay, that's impressive. So Tessel is just fully based on JavaScript, meant for that kind of JavaScript platform. So again, using your skills you already have and leveraging them across the board. Intel's joined lately, and they've made the Edison. The Edison's actually this chip right here. It's about the size of an SD card, but you'll see that this is kind of its development board, so you put it in and you can program it that way and get all the inputs and outputs out of it. Before the Edison, Intel had the Galileo. Did anyone play with the Galileo? I shouldn't say this, but I think it's a little dead in the water because every time you go to the Galileo page, it just sends you to the Edison page. They're like, oh, sorry, redirect, right? So, you were running into that. How many people have played with a particle? Particle is my absolute favorite right now. It's my little baby. I love the particle team. They work so hard. And Particle, they have a core and a photon. They run you about, I think it's like 30 to 40 bucks. Totally Wi-Fi. You can, if you're a Node person, you're going to love this device. I'll show some examples. This to me is like, I probably own about 7 of these right now. It's embarrassing. I think they see my orders come in and they're like, cha-ching, right? Like, it's embarrassing. You've got the Teensy again. I mentioned this. This is about 10 bucks. It's kind of like an Arduino clone. You're limited in what you have access to. But again, if you're just making something really, really small and it's not Wi-Fi enabled, you're good to go. Netduino. Netduino for the .NET folks. Again, very similar to Arduino. Airboard, which I haven't really played with yet. I don't know too much about it, but I thought, hey, this is a nice screenshot, so I'm going to put it in. So, yeah, that's how I roll. So I'm going to go on to a little bit of microcontroller basics and just kind of walk through the breakdown of a microcontroller, maybe of a breadboard, maybe a couple basics. Who's into basics? Who wants basics? We got a couple people. The rest of you can go get a coffee. See you later. Go have a beer. All right. So let me just do this. And let me open up QuickTime. I'm always afraid, like, my dad's going to message me halfway through a presentation. Like, hey, girl, what's up? Be like, oh, God, Dad, you're embarrassing me again. OK. Let's see if this is going to work. All right, so I got my own little Elmo camera. You know you're a nerd when you have one of these. I bought this and had, like, a nerdgasm in the store. I was like, oh, Elmo, I can't wait. So excited. So, OK, does anyone have a pen, perchance, that I can steal? Oh my gosh, people are looking at. Does anyone have an analog element? Throw it at me. Wow. No comment. Okay, breadboard basics. I'm going to go through some real basics here. I'm going to try to make them entertaining. If you're asleep, just do it with your eyes open. So, if we're looking at a breadboard, a lot of people get breadboards. They have no idea why we even have them. You guys can see that, right? Yeah. Is that better? Telling me what to do. Let's see if I can take apart. Breadboards are used to kind of quickly prototype your circuitry designs, I guess is the best way to say it. And if I kind of take away the backing, any kind of starter kit you get with Arduino or with Raspberry Pi, you can buy the starter kits. It costs like 50 bucks or so. If you don't know where to start, buy one of those, because it's going to give you everything that you need. It's going to give you the wires. It's going to give you all the electronic components. You'll be surprised what you'll forget. You'll be like, oh, I need resistors. Now I got to order resistors. Oh, I need this. Like, get one of those kits if you think at all you're going to start playing. They're worth it. Okay, and breadboards, you'll see the breadboards kind of have these wires that go across and then up and down. What these are is actually, they're wires that run across and they kind of got little clips all along in them. Okay, and what that is it's kind of like plug and play making your circuits, right? Because if something's connected together, you're completing that circuit. And so, if you're looking at a breadboard, you have two kind of power rails here. Okay, and red is going to be, you know, power, you've got blue for ground, and these run on the vertical. So that means that underneath the wire, you'll see it's running on the vertical here. They're not connected, okay? And these across are the terminals. And so if you're doing any of your connections of putting in, you know, let's see if I can put in like a wire, for example. Yeah, I wouldn't put red there, but you know, these go across. So if you have something in the row beside it, you're making that connection. Otherwise, it's separate from the row up top. So they run across. And you can, again, take off the backing of your breadboard and see that there. Okay? This middle part, actually, I like to call it the ditch. It's like confusing. You're like, why do they do it? These two sides are separate from each other. And the reason is because a lot of ICs or integrated circuits, like if we're looking kind of here, an integrated circuit actually looks like that. You'll see that it has teeth on either side, right? These connections on either side. The reason why they do that is because you don't want to put that little chip in the middle, otherwise both sides of it will be connected together. So they create this kind of separation, this ditch, and you can jump across between them and you put the chip in the middle. So that's breadboards in a nutshell, okay? Breadboards are something that you're going to have to use at some point. Now, if we're looking at an Arduino, okay, I'm not going to go through step by step what everything is, but I just want to explain a couple of things. Better if I do this way, right? Because you guys don't want to look upside down. So an Arduino, we have, again, an IC. So an Arduino is considered a microcontroller, not a microprocessor. Okay? A microprocessor would be like a Raspberry Pi. Microcontroller is all self-contained. It can't really throw RAM off onto anything. You load a program in on it, and it boots up, and it starts, and it runs with it. Okay? And so, again, so you're dealing with things like limited memory, right? So you want to go call an API and parse that API and all the stuff that comes back with it. Well, guess what? Parsing APIs and string manipulation takes up memory, right? And you got to be careful on what you're using and how that's going to work. So you have your IC here, your integrated chip. And again, these are chips that it's like an Atmel chip that you can go and just buy. So if you really, really know what you're doing, you can go buy this chip for about $5, okay? And you can program it independently of even being in an Arduino. We have what we call Gpios, right? Gpios are general purpose input-output. This is why you get into what I'm showing, and this is why you're in this room, right? Otherwise, you'd be doing whatever else is going on. I don't know, I randomly throw stuff, right? But GPIO is the idea of you want to get data from your environment, or you want to change stuff in your environment. Physical world, right? Installations, sensors of every sort. Do you know, has anyone ever taken a look at all the sensors they have on like SparkFun or Adafruit? It's out of control. Heart sensor, bendy sensor, alcohol sensor, methane sensor. Like there's everything. I just gave everyone in here an idea. I know I did. Right? Pressure sensors, right? So you have input, getting the data in, and you have output. Output might be like your LEDs, might be your servo, might be your robot, okay? And so you'll see that we have what's called digital and analog. Analog is going to be, on these, it's anything with the A. So you'll see you have a limited number of analog, and then you have digital, okay? Digital means it's kind of like it's 1 or 0, right? It's on or off. That's what a digital signal at its very core is going to be. Now, I know there's a bunch of you are going, that's not right. That's cool. This is a basic of how I'm going to explain it. Analog is within a range. Analog, so if you think of digital as it's black or white, analog has shades of gray, okay? So when you think of a temperature sensor, for example, that might be analog, because it could be within some values you're expecting, okay? And then you have these ones that got these little tildes here, and that means that they are pulse width modulated pins. And so that's, instead of sending a signal on or off, you can kind of send a variety of signals in that way. So at its base, that's what an Arduino kind of looks like. Now, for going to the Raspberry Pi, you'll notice the beauty of Arduino. Look at everything's labeled for you. Thank you, Arduino. Thank you, right? Like, this is when you start to give them your hearts, you know? You look at Raspberry Pi, they're like, good luck, sucker, right? And Adafruit, does everyone know who Adafruit is? Okay, who doesn't know who Adafruit is? Let's do it that way. Okay, so there's two companies I'm gonna mention quite a bit, and I have resources, I think, at the end if I was smart enough. There's Adafruit and SparkFun, okay? So both companies sell components, make components, anything you want to do around electronics. They both have awesome tutorials. They both have really great communities. They're both lovely companies, okay? I am pro Adafruit all the goddamn way, all right? Brooklyn-based, intelligent woman, MIT engineer, started the company on her own, and has no time for anything else but helping people with their projects. Amazing. Again, SparkFun, they're great. Where are they? They're Colorado, Boulder. They're Boulder, right? Again, lovely company, really smart. All I know is that in Adafruit, if I order something, I get it the next day. And I am such a fan of that. So she built something that's called a cobbler. And it's this little piece you can get, and you put it on top, and it'll label all the pins for you, and it makes it nice and easy. You don't have to do that. You can look up a diagram and figure out how they work. But that's, you know, basically a Raspberry Pi. It's not that big. It's like the size of a credit card, right? And you can imagine using this for a variety of things. There's also a little camera slot here. Has anyone played with a Raspberry Pi camera? There's like a little camera you can buy. It's about 30 bucks maybe. It's like 5 megapixels, I think. And it's really good. I bought it. I'm really surprised. And it's super easy to use. Like, it's dead easy to use. So, you know, Raspberry Pi. I'm going to show you a couple more. This is the Spark Core. This is the first one they came out with. And again, you'll see the number of pins that you have. You get quite a few number of pins. These things are really easy to work with. They came like that. Now, they came with a Photon, which is, again, it's like the same size. It's got some added features, right? And they did this as a Kickstarter, I believe. I could have that wrong. Now, the interesting thing about Particle is they kind of have like a whole, there's 2 or 3 ways to program it. And so you can actually use an online version to program. And what it'll do is once you kind of connected everything and it's hooked up to Wi-Fi, it'll have an ID. All these have like a specific ID. And what it'll do is it'll deploy the program if you want to work in their browser, for example. Or it'll store data for you. They do a lot of stuff for you. They've really thought about it as a platform rather than just selling a device. So those are some like basic devices I want to go through. Now, let's see if I can exit out of here gracefully. Oh, okay. This is the other thing I was going to just do for 101. This should be interesting. What's interesting to me, because I'm a nerd. You guys are seeing insight to my life right now. It's very embarrassing. All right, so this is one of these kits that you can get that's like an all-in-one. Again, feel free to come up afterwards and check it out. I'm going to show you guys resistors. Resistors are components that you need. And which ones are these? 10. Okay, let's see if I can do this. Oh, hey, that's lovely. Anyone want a seizure? All right, let's try it again. I'm not claiming I've mastered this. Okay, resistors. Resistors' jobs literally is to do exactly what it says, which is nice, right? Isn't that too intuitive? You do what you say you do. They resist current, right? Sometimes they're considered what people would call voltage dividers. Does anyone remember Ohm's law? Yeah, like I barely do. I had to look it up. I was so embarrassed. I was like, oh, cut back to me in grade 11, skipping school, right? So resistors, basically, if you took apart these, and I do this all the time, I buy components and I'll take them apart because I'm weird that way. Judge me later. And it's basically like coil, you know, kind of like wire coiled up in a helix, and it's got some insulation and it's wrapped. And they're really tiny components, and so you're going to want to put them when you need to kind of limit the current that's coming through, right? Because if you're dealing with any of these, you're going to be getting 3.3 or 5 volt. And so with these, you can kind of protect that current and figure out to make sure you don't blow into your components, and you have to check what your components use. Now, something like an LED. You got to be careful, right? An LED, they're sensitive. They're diodes, right? Semiconductors. And that means they can't really protect themselves. And as a diode, it means that they just allow current to go in one direction, positive to negative, right? What is it? Anode to cathode. And so you want to kind of, see, nerd all over the place right now, right? And so you got to be careful because they have no ability to resist. They're like your friend you take to the bar that has the rubber arm and you're like, hey, let's have another drink. They're like, okay, right? Like, it's always a good idea. That's like LEDs. They just have no sense of like how to protect themselves from what's going to happen, right? Which means they're going to pop and explode at some point, right? And so resistors, if you look at resistors, there's always these bands, right? And so when you're trying to read a resistor, I'm going to give you very useless knowledge that none of you are ever going to use again. You want to look to find the one band, and some of them are 4 bands, you might have 6, etc. This is a 4 band. You want to look for the one that's silver or it's gold, and that band is what we consider the tolerance. And the tolerance is basically like, okay, I'm not the most accurate thing. Give me 5% under, 5% over accuracy. That's what tolerance means here. So you can kind of see like, it's not going to be exactly 10 ohms, for example. Maybe just a little bit or a little bit over, right? So you always want to look to find that band and put it to the right. And then all the bands following up that, they actually kind of hold a certain place, and each color represents something different. And so, let's see if I can set it down. And so you have to look up, you can look up a color code chart. There's an app for that. Of course, there's an app for that, right? And you can basically say, if it's a 4 band, you want to say the first 2 bands, they're going to tell you the digit. So, you know, it might be, for example, you know, black and brown. You figure out what those are. You know, that makes your digit. It might be 10. And then your third one's a multiplier, right? And so they actually have a code to them. What I suggest you do is just keep them in the goddamn bag, right? Like, come on. No one needs to know any of that crap, right? But you do sooner or later, because you step on it in your apartment and you're like, oh, what's that? And then you're like, oh, it's a, and then you get all nerdy and you look it up. So, couple things I wanted to go through here. Let's just go turn, yep. Yeah. Am I still golden? Still golden. Okay, so as a JavaScript developer, as a web developer, you have some really interesting opportunities in working with these devices right now. And it's not just as a JavaScript developer. I'm going to obviously focus this on Node, not going to lie. But you know, depending on what languages, if you like to write in Python, if you like to write you know, C++, C#, any of that kind of stuff, you have actually some opportunities for you, and you have some frameworks for you that are interesting to work with. Now, when we think about how communication happens between an Arduino, you know, and your computer, for example, we're talking about serial communication, right? And serial communication is basically async serial protocol. And what that means is that you're sending data bits one at a time. Okay? And when you're thinking about this protocol, you have a couple of ways to configure it. And so you have data bits, synchronization bits, parity bits, baud rate. The thing that you're going to care about the most often when you first start is just going to be baud rate. And baud rate is really the speed at which you're sending those items out. By default, most stuff that you're working with, you're going to see 9600. That's going to be your baud rate. Okay, there's a couple, they'll have a list of standard baud rates. 9600 usually works for most people. If you're doing some Raspberry Pi stuff, you might go the next most standard up, which is a, let's see if I can get, yeah, I can get nerdy. 11520, I think, is the next one up. And what you want to make sure is that your device and whatever you're connecting to it, or whatever program you're running, that they have the same baud rate, right? They want to be running at the same speed. You don't want them to be like running at different things, like trying to pass a baton, right? Like, I'm trying to give you a bit, catch it, right? Same speed. You want to pass side to side rather than, you know, behind in that sense. And so when we're looking at that, you have a bunch of variety of languages that you can use. How many people write Python? I like Python. Yeah, Python. Yeah. How many people do Node? No, yeah. PHP. Yeah. How many people admit PHP? Yeah, I still admit it. C#, how many people have done processing? Yeah, processing, right? All these, you have all these abilities. This is only some of them, but the whole idea is just leverage what you know, okay? And you can get started with these items very quickly and leveraging what you know. I'm going to go over some frameworks, and I'm going to show you a couple of demos. So there's a whole bunch of JS or Node frameworks out there for you that you can use. And so if you're a Node person, this is going to be right up your jam. Cylon.js, has anyone heard of this one? Right, this company has actually a couple of different ones. They have one for Ruby, they have one for Node. Cylon.js, basically all these frameworks are abstracting, like any framework, right? Abstracting the most common things you do over and over again. That's really what a framework tries to do, I think, at its core. Who wants to argue with me? Bring it. Bring it. Yeah, I saw your presentation yesterday. I gotta be careful what I say. We're gonna be wrestling later. So, at its very core, you got frameworks that provide, a sense of abstracting common things, right? And so Cylon, again, does all this. It allows you to connect to a variety of devices. It's not just about Arduino. It's actually, if you look at what they support, there's a whole bunch of things they support, from the Edison to the Raspberry Pi to all sorts of stuff. But the beauty here is that you're writing in a language that you know, right? And so all that idea of dealing with beautiful asynchronous communication, as we love in JavaScript, all that kind of stuff, you're very familiar with it, okay? And I'll show an example of Cylon after. And it's, again, I'm just showing simple examples. Johnny 5, anyone heard of Johnny 5? Johnny 5, yeah, Rick Waldron. Anyone do node bots? If you don't do node bots, look it up. There might be a meetup around you. Node bots are the idea of robots controlled with Node, right? Has anyone heard of Sumo Bot Kit? Oh yeah, I'm gonna drop this all over you guys. I'm so excited. Sumo Bot Kit, if you do not know what to make, and if you have kids, okay, or if you're just a big kid, I don't know. Sumo Bot are the idea that you create robots that you can control. Maybe it's through Bluetooth, maybe it's through IR sensor, maybe you're that person who just has a long USB cord, I don't know. And you have a ring, basically, or a box, a contained area. Sumo, a contained area. Let's just, I'm not going to dictate what shape. Okay, and the idea is you're trying to fight these, it's like battle bots. You're trying to fight these robots against each other, and whoever pushes the other one out of the ring loses, right? Has anyone seen this before? You could probably check SparkFun, probably records all of their stuff. It's out of control, some of this stuff, these little robots that people build. But that's the idea behind node bots a little bit, is creating these little robots. Now, Sumo Bot Kit, if you look online, it should be, you can probably just look up Sumo Bot, it'll take you right there, Sumo Bot Kit. I think the guy's name is Pascal, I can't remember his last name. I can't pronounce it anyway, so I'll say I can't remember. He's from Las Vegas, and what he did is the parts to build a basic robot, the wheels, the base, all that kind of stuff that you can laser cut. He just kind of, put the PDF up there. He put all the parts you need. He put everything that you could possibly want, and it's up on GitHub. So you can download it if you, I know you all have a laser cutter sitting in your backyard, right next to your smoker and your barbecue. But if you have access to that, you can go and actually cut it out. And they make really, I have one, but it's not here, it's upstairs. Didn't bring it. They make really small little robots that all you need to do is go buy some servos, right? You need to get continuous servos. Servos are the little motors, right? Kind of like this that you can't see from there because this is so tiny and useless. Servos come in two flavors. Continuous and positional. Continuous will cost you more because they go continuously around. Okay, positional basically does from 0 to 180, with 90 being its resting point. So you got to buy a little bit more expensive servos, but you can go buy make yourself a Sumo Bot. Please just do me a favor, just leave right now, even if you want. And just go look up Sumo Bot competitions online, or trying to think what else they call them. I forget what SparkFun call it, but I'm sure you'll find it on their AVR day. They had a whole thing about it. So Johnny 5, anyways, was created out of that. Johnny 5 abstracts all those things that you might want to do. So if you want to blink an LED, if you want to use a servo, it just abstracts that code in a language that you're more familiar with rather than writing something in an Arduino, for example. Okay? There's a couple other frameworks. I don't think they're as popular, at least not amongst the makers that I know. You have Node-RED. This is more kind of like, you'll see it's more visual and you're kind of plugging things together, more block-oriented. You have Device.js, which I meant to look at the other day and I haven't looked at it yet. So I can't really give you too much info on that. But you do have these frameworks. And again, if you work in different languages, you will find some frameworks that do some of that basic stuff for you. Now, a lot of the frameworks deal with the Gpio, handling the pins and everything else, right? They don't necessarily do anything along the lines of saving your data, right? Or any of that other kind of stuff. So when it comes to actually saving your data, putting it into the cloud, a lot of that falls on you, right? So you might have to figure out what you're going to use. Maybe you're a parse person. Maybe you're just going to create your own API with Node.js and Express or whatever. Maybe you're, whatever it is, right? But you're usually in charge of that stuff for most frameworks. Okay, demo and stuff. Obviously, I didn't know what I was going to do here. So I'm going to show you. I got time, right? Yeah, I got time? Okay, good. Oh, wait, I got 15 minutes. All right, let's. Oh my God, someone's really counting. Holy, the pressure. Ting, 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 ting. Okay. So I'm going to show you a couple of examples. Okay, vanilla example. Sorry, let's turn display mirroring on. And let's bring up Visual Code. Okay. How many people have tried Visual Studio Code? Oh my God, can I get everyone's hand up by the end of this weekend? That would be so exciting. How many people like it? I'm a fan, man. Look at that. Look how beautiful it looks. Job done. All right. I actually really do like this, especially if you're writing a lot of Node. So if we're looking at this idea of communication between your Arduino and between the language, often what you need to do is you need to put some kind of a program that's running on your Arduino, right? And so what you need to do there is, if you're using, this is going to use Node Serial Port. So Serial Port's a library. It's created by, sorry, does someone know the name? Yes, thank you. I was just like JSConf, that's all I know, and RobotConf. And so basically, this module, again, just like any other Node module, right? You use it, import it, and what you can do with this module, and I might not actually run it because I'd have to put something on the Arduino first, but what you do on the Arduino is you write a simple program on the Arduino, and I might have, yeah, I didn't put it on here. You write a simple program on the Arduino, and all your Arduino is going to do is going to write information. So let's see if I can. I'm not going to run this example. I'll run one of the other ones. But let's open up Arduino. How many people have opened up the Arduino IDE before? Yeah, it's bare bones, right? So we want to go open. Sorry. Maybe I didn't save that example. All right, well, I didn't save this example out. But what you want to be doing here is, if we go avoid setup, Arduino Sketch has basically two main calls for you. And setup is like what you get called once. It's right when it boots or right when you hit reset. And you want to start the serial, and then there is void loop. Loop gets called all the time. Now, loop isn't like a consistent frame rate, so don't get confused by that. Loop really gets called every time that it completes what's within it, and then it calls it again. So it's not going to be a consistent frame rate. And what you'd want to do is you want to do something like, you could do a print line, for example, and I could go Stacey, right? For example, I might be reading a sensor here, and I might just print out the values of the sensor. And so what you're doing is you're writing a program on the Arduino that's printing out that information, or it's writing that information. You can check for it to be writing that information, but then what you want to do once you've done that is to actually connect it to your Node program, is that you're going to want, and this again is going to be in a GitHub and I'll give it to you, you can use serial port. And what serial port requires is it requires the COM port that your device is on. So how many people here are Windows people? Okay, so if you're Windows, you go to your device manager, you go to the COM port, you can see what COM port it's on, you know, like very, very simply. If you are on a Mac, you can go, let's go clear, and you can go ls, can we see this, dev? Right, and it's going to list all of those items. You can go dev.tty or cu, and it's going to list all those items, and you'll see that that's what it's connected to, right? And so all this library cares about is that when you create this, you give it the port, you set the baud rate. So remember that baud rate, how fast I'm communicating is the same here as it was in the Arduino sketch. And then this line here is basically saying serial port parsers read line. I just want to read the line, not bit by bit. I want it to just read the whole line. And you can just capture any of the events. So you have your open, your data, close, error, and that's how you capture information between the two with serial port, which is very, very easy. Now, let's go to an example that is going to be open recent or open. Okay, this is Cylon. This is what Cylon looks like. And Cylon basically, again, if you look it up, you can start to see all of the other items that it supports. But you'll see that it has connections Arduino. And what this one needs you to do is that you basically pass it the port again. And is that what my port was? Boop, boop, boop. Oh, wrong monitor, sorry. Let's just close this out. So 1421, so I got 1421 listed there. Okay, and what it's using is saying the adapter. It's basically saying what adapter, what kind of program are you running on the Arduino, and what you can load on your Arduino if you want to directly connect to it and directly control things like LEDs and servos. You can load something called Formata. Okay, and Formata, again, is basically a program that's a protocol that allows you to talk to your Arduino. And so let's see if this is going to work. This is like, oh, I'm already in demo 2. Awesome. All right. So node, boop, boop, boop. And I'm connected. All right. And can't see it here because I'll have to switch. Oh, I can do it. Hold on. Elmo cameras, they're so nice. Let's see if you can see this. So you'll see this little light up for a bit and then it'll shut off, which is what that sketch is doing. So anytime you're using pin 13, there's actually an LED on board in Arduino. And so you can override it by shoving an LED in there or creating a circuit, but right there you'll see that it's lighting up. And that's how easy, it's just a few lines of code. And all you do on your Arduino is when you're working with your Arduino, you can literally go File, Examples, and just put on Formata and put on like a standard Formata, for example, upload it to your Arduino and you're good to go. And so that way I can start to work with all the components on the Arduino very, very quickly with anything like Cylon. Now, if I'm going to show you the next example, open, boop, boop. All right. App. Okay, Johnny 5. Johnny 5 has so much stuff built in for you, and it also has so much stuff that is like so many examples, so easy to run in. Now, a lot of times, to be honest, I don't use some of these frameworks. Sometimes I find that they're a little overkill for what I'm doing, but once in a while, depending on what I'm writing, I'll definitely use these frameworks. And so, if we're looking at the servo, again, these mini servos, they're pretty useless, right? They're like $7, $8. Servos, when you start thinking about servos and what you're using them for, you got to be very careful about kind of like what you're going to be moving and what you're going to be pushing. Servos have like torque. You know the idea, when you go to open your jar and you're like doing that motion, that's torque, right? And so servos, depending on what you're doing, what size they are, you got to be careful of that. This is not going to do a lot, but it's good to get, as a starter kit. And if we plug this servo in to everything, so 5-volt. Thing with servos is they take a lot of power. And if we go up here, Control C. I know you like to see me live code, it's awesome. Okay. And actually I could just run it from here if I want. Launch. Okay, and what pin am I at? I'm at pin 10. Oh, and I need to make sure that I've got everything plugged in. One sec, can't see what I'm doing. Come on, baby. Oh, forget it. That's a fail. Oh my God, I'm gonna get sick. Whoa! Wouldn't that be a great story for you all? All right, that's awesome. So this servo, what this servo is gonna do is it's basically gonna do like a sweep motion, and it's gonna go, in between them. The thing about servos that you gotta worry about a little is that servos, especially if you're gonna run a bunch of them, take a bit of power. You got to be very careful about your power. If you're going to run Neopixels or pixels, you got to be careful about how much power they take. And so you got to be careful just in the sense of like if you can offload your power and create your circuit in a different way so you're not grabbing power from your microcontroller, you might be a little bit better off. Now the last one I wanted to show was Tweetheart. And let's see if I can plug this sucker in. So come up after, and you can see like all the grossness underneath it. But Tweetheart, open, let's see. Oh, it's here somewhere. Sorry, one sec. There we go. Demo 3, code on the beach, documents. When you're in between a Mac and a PC every day, whew, you get schizophrenic. Okay, so this is Tweetheart basically, and what Tweetheart is I'm using the Spark core. And the Spark core, again, you can program it very much like an Arduino. Super easy to get up and running. And so what I did with this is I created all the animations straight on the Arduino, just to make sure I could get the animations. Now I'm gonna give you a couple things to think about. When you are working with something like this and you see all the colors fading up, you're kind of doing that animation-wise, right? Just as you would anywhere else, right? Delay a second, delay a second, delay a second, whatever it may be. Now, when you're working with an Arduino, most people achieve that by using what's called delay, right? Delay, whatever it is in milliseconds. Delay is great, but delay suspends the program, right? It's saying stop. And what that means is that at any point in time, if you're trying to build something that's actually taking input, it's never going to get that input, okay? So something like this where I need to actually get input, I need to be reading a Node app and interrupt it, for example, I can't use delay. So just keep that in the back of your mind. There's a couple of ways that are well documented, whether it's timers or like an elapsed loop to get across that, but you need to think about that a little bit. Now, I use what's called Neopixels, available from Adafruit. Neopixels are individually addressed pixels that you can control the RGB of. She's done a really great job with them. They have an amazing library. Has all the animations you could imagine. I took those animations and totally deconstructed them, created my own kind of thing. But it gets you up and running really, really, really quick. You can buy them individually. You can buy them in strips. You can buy them in circles. You can all sorts of stuff that you might want to do. I can't recommend them enough, okay? And working with something like this, Again, what I'm doing here is I'm going to Twitter and I'm reading the streaming API and I'm seeing if anyone's basically favoriting me or, you know, because I'm just that big on myself apparently. I felt really weird even building this. I was like, oh, I don't want to know. Connecting, favoriting, adding me to a list. If someone, you know, basically unfollows me, the heart kind of just goes out. It's like this, like starts off black and then, or red and goes like black and does that a couple times. Like, hey, you suck. Wait, you suck again. Wait, one more time, you're still sucking, right? So, but again, very, very easy to create. And if you're looking at Spark, some of the functions here, they have their own module. And what you're doing is you're calling a function that you're referencing when you build the Spark on their end. And it's basically a function that you're calling and you're passing a value. So I have like, it's called a set mode and I'm saying 3, 5, 6. And then it tells what animation to run here. And so, you know, again, very, very simple in that way. And so if I'm running this app at home, if I've got it all set up and I'm running this and I can run it in the cloud anywhere I want to run it, that's the beauty of Spark because I can put this in the cloud and it's just going to look for the ID. It's going to hit up the API and make that kind of cross call. I can have this totally running. And as you can kind of see, you know, it's not running right now, but things are lighting up in its default animation. So that's, you know, very much in a nutshell, you know, something that you could do that's using some of those items. And again, I didn't use a framework here. I used some modules, but I'm not going crazy and leveraging necessarily a framework and going kind of overboard on that. So let's see. Everyone likes resources, right? So if you want to buy stuff, Adafruit, okay? Spark Fun. If you're going to get started and you haven't even thought about this space before, okay? Go get a starter kit. There are so many options. There's devices I didn't even mention. There's like Gadgeteer. There's all sorts of things that you could be doing. Pick up a starter kit, right? And get the entire starter kit because it's going to give you the wires. It's going to give you all the pieces that you need. Okay, you're going to do the blinky blinky, and then you're going to be like, why did I do the blinky blinky? No one really cares about the blinky. Like, you do the LED, which is a hello world of Arduino, and you're like, yay! Continue. Give yourself a project. Go make your loved one a little box that only unlocks on their birthday, right? Go, like, I could give you a gazillion ideas, right? You can go get a piezo sensor for $2 and figure out like a knock sequence. Go make a secret door that, like, you know, at work that opens up the beer fridge. Like, you know, like, you know, like Leonard Skinner all the way, whole song, asshole, you gotta do the whole song, right? Whatever it is, I don't care, but give yourself a project, because if you don't give yourself a project and you buy a starter kit, you're not gonna get anywhere. You're literally gonna be like, that was fun, right? So, you know, you've got Adafruit, SparkFun, there's make.com. I don't know if they have maker fairs out here. Sometimes there's small individual ones. Look up your resources, look up meetups, right? Often you'll see hardware meetups. There's a lot of hardware and IoT meetups right now. Honestly, I'm in New York and a lot of it's kind of like, hello, I run an IoT startup. You're like, oh, awesome, great, you're a business guy, I don't want to talk to you, right? But you will find interesting people who are doing interesting things there. Make.com, DigiKey if you really know what you're doing. Has anyone been to DigiKey before? Yeah, it's like they just took their Excel sheet and put it online. They're like, ooh, publish, right? So you gotta be very careful because it's just like, I don't know what 11065-59996 is, but I want 5 of those, right? Okay, I could do this all day, by the way. Learn, Arduino. Arduino's got a very good community. One of the top guys in Arduino, his name's Tom Ago. He's from ITP in New York. He has tons of like tutorials that you look at and you're like, should I trust this? Because it's just like a blank HTML page, like he's never seen CSS before. But they're the best ones out there. He's like great, and he's written books, so he's awesome. Arduino, the community is really good. This is a shout out to one of my coworkers. If you have an Edison or you plan to do anything with Intel, he's done so much, and he's got like, here's the 101. Like you literally are like, I'm gonna copy and paste, yay, and you're done, right? Hackaday, has anyone seen Hackaday before? Oh man, I love Hackaday. Just add them on your Twitter right now and thank me later. Like, should you hack your microwave? Yes, you should. right? Who doesn't want a burrito, right? Alcohol sensor, microwave, just gave you all an idea, right? Hackster Io is another community that's up and coming, and they have a lot of, again, tutorials, things that you can learn, things along those lines. You're going to see people in the space are divided a little bit. You get your hardcore traditional makers, right? People who might be, making their garage door openers or their kegerators or whatever. And then all of a sudden, the landscape shifts over into more creative technologists. And so you're going to see people like, Kyle McDonald, for example, or Theo Watson, who are building these amazing, beautiful installations. Has anyone heard of the wooden mirror? Look up the wood mirror. It's one of the most simply beautiful things you can see. And what it is this guy, Daniel Rosen, he made basically, it's Arduino, and it runs with I think also it's got like a camera. You walk up to it, and it's like this beautiful wooden mirror. And the way to describe it is little wooden blocks, like pixels. Each block represents a pixel, right? So you can imagine it's like whatever, 64, 100, and whatever. But they're light and they're dark on either side, right? So think of a chip of wood, light, dark. So it can either be black or white, right? And so what he does is he has a little video camera in the middle, and when you walk in, all of them are running on servos. And he takes your picture, again, he distills it, black or white, figures out the pixels, and then flips all the items to show your picture. And it's like between the sound of the servos, if you've ever heard, which is quite annoying, right? But it makes for such a beautiful installation. So look up the wooden mirror. It's probably one of the most amazing things I think I've seen. And that was done like years ago, right? So it gives you a sense of the landscape and where you're going to. I'm gonna leave it at that. Does anyone have questions? Yes. And then yes.
When you were plugging the pins, when you said you have the interface with the pin, can you expand more on that? Like if you want to get an LED in one of the pins off of the Raspberry Pi?
Oh, here, you're talking about the Raspberry Pi. Yeah. Okay, so the Raspberry Pi here, you'll see that this gives you nice little like notches, header pins to put in. With these, you need more of a different adapter. And these pins, it's basically the same thing as these set up, and you can look for a diagram online, okay? And so some of these are gonna be like your ground, your power, your TX, all those kind of things, or your inputs and outputs. And it's, again, it's the same thing as working here. They just expose it in a different way, right? So it's the best way I can explain it without actually manually showing you, and I don't have a cobbler here to actually show you. But these kind of things, you can look up Raspberry Pi, you can say pins, and it'll give you a diagram, and you can start to map, because each pin has a number, right? So you need to figure out, like, am I plugged into 10 or 9 or whatever it may be. And so you got to look up the diagram. Question? Did you have a question? No? You? 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 Anyone else got a question? Is that it?
I wanted to ask this morning.
Oh, no. Shit. How do I get my employer to give me all this?
Are you doing it on your
Well, they're recording this, and they actually don't know I'm here. I love you, boss. So I'll be very honest. Oh, wow. I feel like we need a circle here. They need a hug. I do a lot of this stuff. I do a lot of stuff on my own time. I'm naturally curious about it. So I'm a person who stays up till, I'm the person you can ping at 4 in the morning. How do I convince my boss? My job, you guys want me to tell you what my job is? Yeah. Everyone's like, what the hell's an evangelist, right? My job is to be a developer who talks to developers and to talk to you about Microsoft, right? So I talked to you about Microsoft today whether or not you knew it, right? I showed Microsoft software, right? I'm showing you things that we support. And so at the end of the day, I have free reign to work on anything I want to work on if I can bring it back to our platform. And that's as simple as it is. So I can be like, hey, can you get me, or hey, I just saw this new drone, I'm gonna go buy it. I'm gonna make an app that's gonna run here, here, and here. We're gonna use Manifold.js for hosted apps, and then we're gonna do this, this, and this, and they're like, awesome, have at it. So I'm really lucky, I guess, but you've got to be very creative. You got to be like, oh, it's going to be awesome. Don't worry, right? And the whole thing too is like you say, well, why? How can I get my employer to let me tinker? And I think that if you're thinking about this yourself, like in your own job, how can I let my employer let me tinker? What you got to do is you got to figure out applications that could possibly come out of it for your employer, as minute as they may be, and show them the possibilities. You guys work for a client. Maybe your client's a health, client. Maybe you're going to take a sensor that's going to do something, and maybe they can use it. So I think it's about being creative that way. I had a much harder time at my previous job allowing them to let me tinker, unless I had a specific thing that was like, oh, we have this client, and it's we had a Finish Line, for example, and this would be awesome. I think I'll prototype it. Just don't worry about it. Don't worry about my job and my workload. Everything will get done. Just let me do this. And if you kind of do it that way, most people will be like, oh, okay, all right, or whatever. That's how employers sound to me. I don't know. I love you, boss.
Just wondering how much or why you like Node.js and Python.
Why do I like Node.js over Python? I don't like either. I'll equally do both. Yeah, I showed Node today, but to be honest, if I'm using Raspberry Pi, I'll probably use Python more often than I'll use Node. I've been using a lot of Node lately, and mostly it's because of, I blame Particle. Yeah, go buy one of these. Particle, I just plugged you. Give me some free swag. Anyone? Also on camera. Anyone else? Seriously, anything else? It can be unrelated.
I have a quick question.
Yeah.
So, I did look into .NET Gadgets here when I was
Yeah.
thinking about getting things like.
Yeah.
Do you think that's a good gateway drug to Arduino? I mean, only because it kind of definitely abstracts a lot. It's kind of like.
Yeah. So Gadgeteer. My opinion on the Gadgeteer. I've worked with that as well. My opinion on the Gadgeteer is that if you're like a .NET dev, it's going to be more comfortable for you. And they give you all the pieces, you know what I mean? So you kind of plug stuff in. You don't have to worry about any of the connections. So I think it's a great prototyping piece. I think it's a lot of fun to play with. Is it my favorite? Absolutely no. But if you're coming from that realm, yeah. I know we taught IoT camps for work, which was a lot of fun. I got to teach people how to work with devices. Can you imagine that? It was awesome. Like Raspberry Pi and Gadgeteer. So much fun. And I was really surprised by how many people really love the Gadgeteer. So I don't know. My problem with the Gadgeteer, to be honest, didn't say this Gadgeteer. Can you edit this? Can I just go edit? Price point. It's not the most cheapest out of all of them, right? So, and also I think there's a little bit of wait time there too. And the community's not quite there yet, but it's coming. It's coming. It's growing. Anyone else? Yeah.
So the new Windows operating system for Raspberry Pi.
Sure.
Have you tried that?
Windows IoT. Yeah, sure. Yeah, so you can write like a universal app. The whole idea that Windows, what they did is basically convergence in Windows 10. And so the idea of writing a universal app that you can work across the board. You'll find that the Windows, I'll be very frank. I have no problem being very honest and very frank. It's a work in progress. Like when I first worked with it, I could get like LEDs to work, and I could get a couple things to work. So all their inputs and outputs they're working on and increasing. You're finding if you're like on Insider Preview and things like that, or you're part of that community for the IoT core, you'll find that they're doing drops quite regularly. You'll find that the tooling's going to start to support a lot more of that stuff for devices too. We're going big on devices, like big. Yeah. You're literally, well, again, you can write a universal app on Windows in JavaScript or C#. It's your choice. So you can do it either or. So we support JavaScript. They just abstract all the native layer for you in a JavaScript library, so called WinJS. Any other questions? Does that answer your question? Okay, good. I was like, I think I'm done. Time. Oh my God, I got the time sign. All right, thank you very much.